Hi everyone, welcome to the second video in the series for Segment Anything Model 2. In the previous video, we discussed about how to clone the SAM repository and how to segment the images using different index numbers and the color palettes. We have not seen how to bound the boxes for different objects in the images, and in this video, we'll be exploring that particular part. So let's dive it into the code. Like I explained in the previous video, we had this notebook with us and we used few of the images that were readily available to us. I'll just recap what we have done in the last video. We have just set the home directory, that is slash content. Then we have cloned the Facebook research segment anything to repository. We have installed all the requirements that are present within the setup.py file within segment anything to folder from here, and it installs everything from the setup.py into the editable mode. If you want to know more about the editable mode, you can check out my previous video. I have explained a bit about it. Next, the installation of supervision and Jupyter bounding box widget. Then cloning the different models of SAM2 like tiny, small, base plus, and large. Importing the libraries, setting the PyTorch version, and setting the data type as float 16 for reducing the precision to float 16. The next was setting the home plus the model path, loading the config, and building the model. Next we did was generating different masks, reading out the image in blue, green, red, and converting to RGB format for generating the mask. And we had this dictionary with all the segments available to us within the image. And using this, we visualize the image, the different segments in different color palettes using the indexes over here. Next was we tried to visualize the masks. So we had different masks within the segmentation that we have generated here. Now, the next part comes in where we did was manipulating different parameters and setting different threshold and batch size values and generating the mask again. It took some time to generate the masks because of the higher values. And now here comes the main part that this particular video will be focusing on. That will be the prompting with boxes. So here what we are going to do, we are just loading out the SAM2 model that we have generated. And then we are loading the image. So this is doc2. That's how the image looks like. We are creating a method for encoding the image, and the encoding that we are doing is UTF-8, and we are forming it into the base 64 string format. Now what we are doing is we are using the bounding box widget from Jupyter Bbox widget and initializing the object. Next we are encoding the image by providing the image path that we have defined earlier, and then we are getting the widget. So once I run this, I will be able to see the image. Also, I can create the bounding boxes like this, and for example, okay, let's create one more bounding box over here like this, and we do the submit. If I print the widget boxes, it shows me X, Y, width, and height. Now we are providing a default boxes for these annotated annotations that I have just defined above. So for example, I have defined xmin, ymin, xmax, and ymax consecutively for all these boxes. since we have all these parameters with us. And we'll be using SAM to image predictor dot predict for performing the next masking. So let's just execute this, and now we will generate the mask. Here you can find the description of what all parameters that can be used within. So right now we are going with the default ones. So I'm providing the image in RGB format. Then we are doing the predictor dot predict with the boxes that we have defined above, and we do np dot squeeze. So let's run it. Next is result of visualization. So we'll be again using the supervision library for performing the annotation. So box annotator, mask annotator, we are providing the indexes. So this will be again using the color palette for showing different segments within the image. Again, we are doing the detections using supervision library. Then we are again providing the blue, green, red image and providing the detection for the source image and then for the segmented image. So for segmented image, we are also providing the detections that we have defined here. Next, we are plotting the images, the source image and the segmented image, the grid 1 by 2, and the tiles will be the named as source image and the segmented image. Let me run it once again. All right. So now you see we had these four bounding boxes, and you can see the segments defined with different colors. I think it annotated the hand as well because our bounding box was quite large, so it detected one more part of the image as one of the segment, similar to this particular a piece of glass what is kept in the table. But anyways, it depends on the bounding boxes how you create them. It can create the segmentation that works well. Similarly, if we want to do again with this particular image, and let me just draw the bounding box over here, over here, here. Mm, all right, let's define the boxes again, run through the bounding boxes and the masks, and now we are plotting the grid for different masks. So now you can see for what we have selected, it has provided the masks for them. So it works pretty well, but you have to be careful while bounding the boxes around the image for doing the proper segmentation. And the model is pretty good in doing the processing further. That's it for this video, and let's dive into the segmentation for the video instead of images in our upcoming video. Let's stay tuned for that, and I'll see you later, guys. Thanks for watching.